23A. 100 draws are made at random with replacement from a box. If the sum of the draws is 7611, what is their average? How do we find that? 100 draws. The sum is 7611. Divide by 100, and you get 76.11. If the average is 73.94, what's the sum? 7,394. Okay. Number 3. 100 draws will be made at random with replacement from a box of tickets. Do we really have to do replacement? No, as long as the number of draws is small compared to the number of tickets in the box, and we do enough draws, it really doesn't matter. The average of the numbers of the box is 200. The SE for the average of the draws is computed. It turns out to be 10. True or false? About 68% of the tickets in the box are in the range from 190 to 210. That's a really good question. So this is number 3. So I get 200 plus or minus 10 for the average. Let's do the X bar of the box. Okay. So it's asking about 190 to 210. What does this range describe? First off, is this a probability or a confidence interval? Confidence interval. How come? We don't know what's in the box. If we knew what was in the box, this would be the probability of drawing 100 tickets from the box. 68% of the people would land inside that window. Now that it's a confidence interval, does this mean 68% of the tickets in the box are in the range 190 to 210? No. What does a confidence interval tell me? And you can't use the word chance because that's probability. We are 68% confident that what will land? The true average is in that window. Okay? Please tell me that's what the back of the book said. Somebody double check. 23A number 3. 3A should be false. Yes. Okay, there is a 68% chance for the average of the 100 draws to be in the range 190 to 210. That's also false. What was the average of the draws? 200. Okay. We are making... Wait a minute. There's a 68%. Oh. B was really true? Oh, man. There is a 68% chance for the average. Oh, I'm okay. Sorry, I read this wrong. It says the average of the number in the box is 200. So we do know what's in the box. I read that wrong. Okay. So A is false because it's not 68% of the tickets in the box. It's 68% of the draws will end up being in that. So it is probability. Okay. Whew. That had me nervous. I thought I had it all figured out. But I read the problem wrong. So A is false because it's the probability of getting 68% of the people will land in that window. And B is false because, no, B is true because 68% of the people will land in the 190 to 210. All right. Wow. I about turned in my diploma and walked away. That would be funny, right? Teacher gets mad, grabs his diploma and leaves and never comes back. That's true. To break something. Okay, 4. If you're drawing at random with replacement from a box of number tickets, the expected value of the average of the draws, or the average of the blank, equals the average of the blank. So the expected value for the average of the draws equals the average of the box. And why do we do that? Why do we create a sample statistic and then just throw that number into the box? Because we have no better way to figure it out. That is our best guess if we have done our sample correctly. We assume it's true, and then we run with it. B, as the number of draws goes up, the SE for the blank of the draws goes up, but the SE for the blank of the draws goes down. So which SE gets bigger as you make more draws? The sum, and then the average goes down. Why is that? Okay, that's one way to put it. The more draws you make, the closer and closer your sample average is supposed to be to the actual average. So that window of confidence kind of gets narrower and narrower and narrower. Mathematically, why when the sum goes up does the percentage go down, or the average? What's that? It has something to do with the denominator. So as the draws increase, the SE of the sum also increases, but it's increasing at a slower rate than the draws. The draws are going up by, if the draws double, then the SE goes up by the square root of 2. If the draws get multiplied by 100, the SE goes up by the square root of 100, which is 10. So the absolute error when you make more draws is expected to get larger, but it's getting larger at a slower rate. So as a percentage or an average, it's actually a smaller value. Okay. Number 9. 200 draws are made at random with replacement from the box 1, 2, 2, 3. A, so each one is either true or false. The expected value for the average of the draws is exactly 2. The expected value is exactly 2. True. Do we think that we're going to get exactly 2? No. But our expected value is 2, plus or minus something. Wait a minute. They probably said false on that. It's true? Oh, I see what they're doing. Okay. So the expected value of the average of the draws is 2, give or take 0.05 or so. False. The expected value is 2. What is going to happen would be 2 plus or minus that amount. So the average of the draws will be around 2, give or take 0.05 or so. True. The average of the draws will be exactly 2. So this is just testing your knowledge of terms. Expected value is not really what happens. The draws are what happen. Expected value is just a theoretical possibility of what should happen. All right, and E, the average of the box is exactly 2. True. The average of the box is around 2, give or take 0.05 or so. False. It is 2. Okay. Wow. That one put a tarnish on my reputation.